Hi friends, this is Alok from meherclasses and welcome to the third lecture on set theory. In our previous videos, we had covered different symbols and different types of sets and their names used in set theory. In this section, we shall discuss about different operations being performed on sets. As you know that we have addition, subtraction, multiplication and division in classical mathematics. In the same fashion, we have different operations in set theory as well. These operations are very helpful in solving complex problems. So let's get started. The four operations that we generally have is union, intersection, relative complement, and complement. We shall be discussing these points in much detail in slides to come. And to perform the operations on these sets, we need to have certain values. So we have taken some random elements and three sets, A, B, and C. In A, we have 1, 3, 4, 8. In B, we have 3, 5, 7, 8. And in C, we have 5, 7, 9, and 10. So let's talk about union. So union in general is the addition. And when you want to combine the elements of two or more sets in one, that becomes a union of the sets. It is represented as U. So let's take an example. If I want to find A union B, in A you have 1, 3, 4, 8, and in B you have 3, 5, 7, 8, as you already have seen. The resultant would be 1, 3, 4, 5, 7, and 8. Here you need to remember only one thing, that whenever you find any number which is repetitive in nature, you just need to consider it only once. So here 3 and 8 are occurring in both A and B, so you just need to consider 3 and 8 only once. So the resultant is 1, 3, 4, 5, 7, and 8. Here are some points that you just need to remember. If the same number appears in both sets, include it once in the union set that we have just seen. The union of any set with itself is the set itself. So if you want to combine the elements of the same sets, you will be getting the parent set only. And third one, if you want to take the union of the set with the null set, you will be getting the set itself. That means the parent set. Let's talk about intersection. Intersection is something that talks about common elements. So if you have some elements that are common in two or more sets, and if you want to find out the intersection of those sets, you just need to put it in one set in the resultant set. The symbol inverted U is used to represent the intersection of sets. So let's take an example. I want to find A intersection B. As earlier we have 1, 3, 4, 8 in A and 3, 5, 7, 8 in B. I want to find out A intersection B. So we just need to think that what are the elements that are common in A and B. So 3 and 8 are the only elements that are common in A and B. So A intersection B would be 3 and 8. Now let's talk about A intersection C. In A we have 1, 3, 4, 8, and in C we have 5, 7, 9, and 10. You can see that there are no elements in common. So the resultant would be empty set or phi. So if there are no elements, then the A intersection C would be an empty set. Let's talk about relative complement. This is something which is known as subtraction. So the symbol for a relative complement is always minus sign. And here is a rule that you need to remember. If I say A minus B, that means I want to consider the first set as A and second set as B. So all the elements of set A that is not available in B is A minus B, which is pretty much straightforward. Let's take an example. I want to find A minus B. I have 1, 3, 4, 8 in A and I have 3, 5, 7, 8 in B. So A minus B would be 1 and 4 because 1 and 4 are the only elements of A that are not available in B. Let's take this example. If I want to find B minus A, so B is equal to 3, 5, 7, 8 and A is 1, 3, 4, 8. So B minus A would be 5 and 7. In the same fashion, I say that 5 and 7 are the only elements of B that are not available in A. So B minus A would be 5 and 7. Now let's talk about complement. Complement is something which says that the complement of a set is everything that is not the part of that set. So the complement of A would be denoted by either A dash or A, and C is appearing as a superscript, AC, or A bar. The complement of A is A dash, which is universal set minus set you are working with. So this is something which is very important, and you need to remember this. So whenever you want to find the complement of any set, you need to find the universal set, and you need to subtract the elements of the working set from the universal set. So if the universal set is U, then A dash is equal to U minus A. Now since A is equal to 1, 3, 4, 8 and B is equal to 3, 5, 7, 8, you know that universal set would be 1, 3, 4, 5, 7, 8, and A dash would be A union B minus A. So 1, 3, 4, 5, 7, 8 minus 1, 3, 4, 8. And then here you need to apply the rule of subtraction. So A minus B is something that all the elements of A that are not available in B, it would be 5 and 7, because 1, 3, 4 and 8 are the elements that are available in B also. So you need to discard these elements and just need to write 5 and 7. So in the note it is written at the below, just for your sake, that once you get the universal set, then apply the rule of subtraction to get the complement of the set you are looking for. Let's talk about some properties of a complement. So there are certain properties of a complement of a set. This is the Venn diagram, and you can see that this portion, the shaded area is A dash, because this section I'm considering as A. So whatever is left outside is A dash, and this whole area including A is U. So there are certain properties that you need to remember, that complement of any complement of A would be the original set. That means if I want to find out A dash, this is A, so A dash is the shaded area. And if I want to find out the complement of the shaded area, I would be getting this A. So this is complement of a complement of set is A. Now I want to find A complement union A. That means whatever is the shaded area is, in this shaded area, whatever is written there, the elements of the shaded area and the elements of A, if you want to combine these two, you will surely be getting the universal set. So A dash union A is equal to U. Then you have A dash intersection A is equal to phi, which is pretty much obvious seeing the Venn diagram. Fourth one is universal set, and you want to take the complement of that universal set. If you want to take the complement of that universal set, you would be getting phi, because complement of everything is nothing. Similarly, complement of nothing is everything. So phi dash is always U. So this is the Venn diagram which is presented here for your convenience, and you need to remember these points for your application. The most important part of properties of complement are De Morgan's law. So if I talk about De Morgan's law, in this video I'll just be writing those two laws, and we shall be seeing the proof of those laws in the next video. So in the De Morgan's law, you have A union B, and if you take the complement of A union B, you would be getting A complement intersection B complement. And second one is the complement of A intersection B is equal to A complement union B complement. We shall be looking into the proof of these De Morgan's law in the next video. So thank you for watching this video. Please like, subscribe, and share if you find this helpful. We shall be back with new topics in set theory. Till then, have a great day. Thank you.